Good afternoon, everyone, and welcome to today's session on blockchain technologies. We are waiting for Neeraj sir to join in. So as soon as he joins in, then we'll start with the course. Till that time, if you have any issues regarding your roll numbers or anything like that, you can ask me in the chat window, or you can unmute yourself and ask about that.
Excuse me, ma'am. Ma'am, about the WhatsApp group, some of us haven't been added to it yet.
Okay, Akshat, can you write your contact number in the chat window?
Okay, ma'am.
Me too. I have also not been added in the chat. WhatsApp.
Please write your contact number in the chat window. I'll add over there.
Okay, ma'am.
Ma'am, can you please share the slides in the WhatsApp group?
As soon as I'll get it, I'll definitely share it with you.
Thank you, ma'am.
Okay. Good afternoon, Neeraj sir.
Good afternoon, ma'am.
So we have with us Neeraj sir, so that he can start with the course today. So I have given you the right, sir.
Okay. Got it. I'm audible to all of you.
Yes, sir, you're audible.
Okay.
Yes, sir.
Okay. I think hash PPTs are also visible, I hope.
Yes, it is.
Okay. Great. So on the other day, yesterday, we were discussing about the basic component of this blockchain technologies, right? So today's point of discussion is also more or less the same. I mean to say here, we are more concerned about how to make a distinction between distributed databases and blockchain ledgers, basically. So we have discussed that as compared with distributed database, these blockchain ledgers are more or less are distributed types of record keeping mechanisms, and there are a notion behind this that we have yesterday discussed about the same, that if we have certain hash functions, so these hash functions will generate the fixed length code, and these fixed length code are used to connect different blocks one after the other, just like in chain of a blockchain hash, and then these chain of blocks chain hash are used to interconnect with each other, right? So there are basically as far as cryptography hash functions are concerned, so it's consisting of encryption and decryption of data. So two main cryptographic concepts that had been used in blockchain: one is hashing, second is digital signature. So digital signature are used for finding out the identification of any nodes or number of transactions that has been made by particular node itself. So those can be used with the help of digital signature, while hashing has been used as all of you know, SHA-256 hash code has been used. Hash code algorithm has been used to generate a 64 character code, which is used to encrypt this what we call as data association in a particular block itself. So I hope this point is clear that we have discussed on the other day, that let's say some message is there, right? And in this message, once we applied some hashing algorithm, so it is a fixed length code that we have to play it with. Similarly, if we use some symmetric or an asymmetric key encryption algorithm, so that is all concerned about using of some public or private key, and using those public and private key, we can use it out for encryption and decryption mechanism, right? So similarly, in case of symmetric encryption, we can use only a single key that is used to encrypt or decrypt the data, and the other part is used for two types of keys to encrypt or decrypt the data. So like you can see, you can check it out at here, that let's say we have some data association. Let's say 2 3 4 5 is there, we use some public key, let's say multiply it with 1/3, and on the other side to get this data, again we multiply it by 3 to get the original content of the data association, right? So so it means to say that using those cryptographic hashing mechanisms and digital signature, we will be able to generate fixed length code, or we can be able to make some sort of what we call as symmetric or asymmetric encryption algorithms. So it's all about making out this data, which is an input data, to make it some sort of operation on it, and then we can check it out what sort of output has been obtained. So like for example, if we are using this SHA-256 hash, so this SHA-256 hash, so while we have some input data, we are applying this hash SHA-256 algorithm, then we will get the 64 character code, that is 256-bit code, that is used to check out the authenticity of any block. Yesterday also we have discussed that if we have just changed this character, let's say we have hello h, then this we can generate a new hash. Similarly, even if a single character has been changed it out from the input value, then we will get a completely new code or completely new hash value. So this is the beauty of this SHA-256 hash algorithm, that while we are changing even a single digit from this input value, then we will get a whole set of new we can say hash value that is to be played with, right? So this is the beauty of this algorithm. So like here also, if you are using this asymmetric encryption, then let's say hello has been encrypted using, if we are using, let's say RSA 1024, so we will get this type of encoded code, and again by applying this private key, again we will get this type of code. So this is called as a encryption and decryption with the help of RSA, that is asymmetric encryption algorithms. So I mean to say here that with the help of this public and private key mechanism, we will be able to get out the desired output, and using those desired output, we will be able to get it out the desired operation that is to be performed on the input data set, right? So then we will have the notion of this consensus component. So the consensus components is basically upon the principle of and this Byzantine fault tolerance. So there's a very good story on this Byzantine fault tolerance, that how this Byzantine fault tolerance has been there. So the story was that Byzantine was a king who used to make a plan to attack on a castle, right? And if he has make a plan to attack on the castle, right? So there are, let's say, 4 or 5 we can say supporter for him out of, let's say, 10 attackers. So out of these 4 or 5 uh, let's say 5 we can say attackers are in favor of his decisions, and rest 5s are not in the favor of decisions. So it's a 50-50 ball game together to attack on the castle or not. But if we will have, let's say, 6 votes that are favor to attack that particular castle, and rest 4 are not in the favor of attacking the castle, then in that case the attack will be successful, and it has a common consensus mechanism. While if there are, let's say, less number of votes to attack on the castle itself, then we can say that this that this consensus algorithms are not there, and then in that case there may be some sort of deferred decisions with respect to the castle operation on that particular scenario. So I mean to say here, to attack or to make a common consensus algorithm, so I mean to say here that this BFT is a consensus based algorithm which will work on that how to defend against failure of a system component with or without symptoms that prevent other component of the system from reaching an argument among themselves, where such an argument is agreement is needed for the correct operation of the system. So I mean to say here that, let's say, out of 10 cases, more than 50% are in the favor of taking a particular decision. So it's all about how you will make a consensus algorithm within the different parties, so that a common consensus can be reached out. So let's say one example of PFT is in Bitcoin. So Bitcoin networks work in parallel to generate the blockchain with proof of work. This allows the system to overcome the Byzantine failures and reach a coherent goal view of the system states. It means to say that if more than 50% are in the favor of taking decisions, then only the decision will take care of, and that is called as BFT tolerance for execution in a particular system, right? So it is based upon blockchain consensus algorithm. So this consensus algorithm is that behind every cryptocurrency there is a consensus algorithm, and this consensus algorithm is based upon, let's say, proof of work, that is proof of stake, delegated proof of stakes, proof of burn, and PBFT, that is practical Byzantine fault tolerance mechanism. So there are a number of we can say consensus algorithms are there which can be used it out to make a common consensus among all the decisions which are to be taken care of by different parties. So usually what type you will be wondering that what type of decision are needs to be taken care of. So decision needs to be taken care of that whether a block should become a part of the blockchain, and how many number of transactions should become as a part of the blockchain, and what sort of transaction should becomes or committed to be part of the blockchain. So all comes into play so that common consensus algorithm can be executed by miners, and then we can make a block as a part of the blockchain, right? So like for example, if we are dealing with the block proof of work, then the probability of mining the block is dependent upon how much work is done by the miner. This is called as a proof of work because miners are the parties which authenticate the number of transactions which are supposed to become as a part of the block. And how does these miners will work it out? So these miner will find out using some algorithm. They will try to find out which transactions are supposed to become as a part of the blockchain, and they generating constant hash, and using those constant hash they will try to mine the input data, and based upon that input data they will check it out that how much work has been done by a miner, and these miners are divided finally. And then this type of mechanism in which miners will work it out that how much work has been done is called as a proof of work. Similarly, second is proof of stakes, that is person can mine depending upon how many coins they hold. So it means it's all about how much stake they have in the blockchain. It means how much wealth he has in the blockchain network. So normally payout becomes smaller and smaller for Bitcoin miners. There is a less incentive to avoid a 51% attack. So if we will have a 51%, I mean to say 51% stake on the blockchain networks, then proof of work will work successfully. And proof of stakes makes any 51% more expensive. It means to say that whosoever has a higher stake in the blockchain can make efficient decision with respect to the mining. So proof of work system have powerful mining computing. They are tend to become centralized over time, and proof of stake systems are more decentralized, but most of the work hard to build communication around the coins. Then the blockchain structure. So how this blockchain structure will look like in a generalized scenario. So based upon this centralized repository, you see that the earlier we have a centralized repository which is to be monitored by a centralized administration person. So now it has been completely decentralized, and now each of these party can participate in the blockchain networks. They can make their own transactions, and they can also everyone has a full stake or full we can say authority to make or decision with respect to the inclusion of different blockchain or different we can say transaction which are supposed to become as a part of the blockchain in a blockchain networks. So it is blockchain basically is a peer-to-peer architecture with pseudonymous clients bearing key pairs, and each node as a database copy. So let's say This is pseudonymous client. This is pseudonymous client. This is pseudonym client. So nobody knows each other entities. These nodes are located across different geographical locations, and all of them are working on a public ledger. So each of them maintains a copy of the blockchain, and each one of them maintains the copy of blockchain. And let's say if we have to make certain decisions, so then these decisions with respect to the inclusion of any, we can say, transaction as a part of the blockchain can be summarized or can be taken jointly by all of these based upon common consensus algorithms. So this is just like a decentralized peer-to-peer database repository. There is no centralized authority in this case, so no need to verify the transactions from the centralized authority. These are the persons or these are the entities, like pseudonym clients are there, which will take decisions collectively with respect to the common consensus algorithm. So how does the structure of the blockchain will look like? So you see that yesterday also we have discussed that there are some components or attribute associated with each blockchain network. The first component or attribute is block ID. So let's say this is block number 0, this is block number 1, this is block number 2, block number 3, and so on. And similarly, we have some nonce association for each block. This nonce is nothing but it's a timestamp when that particular block has been created. And then we have the notion of this hash value. So this hash is again 256 bit SHA-256 hash, that is generated some hash for that particular block. And if it is Genesis block, so previous hash value will be nothing. So in the next we have this previous hash value. So you can see that this previous hash value is exactly the same hash value at here. So this previous hash value should be same at here, or I mean to say this previous hash has been there. So this previous hash has been there. So these hash value should be same. These hash value should be same. These hash value should be same. So yesterday somebody was asking that if we have some attack on the blockchain networks, let's say we have attack on the blockchain networks at block number 2. In that case, this hash value has been changed it out. So let's say this hash value has been changed it out. So in that case, these two value would be different. So consecutively are these subsequent blocks, this block number 3, 4, 5, 6, 7, 8, 9, 10 up to let's say 100 or 1000, all of these blocks becomes invalid in a blockchain networks. And if such that thing happens that all of these blocks will becomes invalid in a blockchain networks, then we will say that there has been some sort of attack that happens on this blockchain networks. And if attacker has to become successful, then he has to change the hash value of all these subsequent block, like block number 3 onwards to block number 4, then block number 100 till 100 or 1000 or any number of blocks that has. So beyond this block number 2, everything has been changed out and this chain will becomes invalid. So in that scenario, you can see that it is impossible for the attackers to change these hash values subsequently from this block number 3 onwards to let's say 1000 or let's say 10,000 or let's say millions or any number of nodes beyond this particular block itself. So in that case, you can see once miner mines these blocks, so these values, previous hash values, the current hash value which are located in this particular blocks, so these becomes invalid. So in that case, you can see that how much secure this blockchain is there, that even if we have changed some values, so the previous hash value which has been located in a particular block will becomes invalid, and these two values will be different in that case. So we will easily can identify that there had been some attack on the networks by some attackers. So that's why blockchain data would look like this, like it's consisting of 256 bit hash value that is to be encountered in this case. And there are various types of blockchain. So there are different types of blockchain. One is public blockchain. So in this no one is in charge, so anyone can participate in reading, writing, auditing the blockchain, like Bitcoin, Litecoin, etc. These are examples of public blockchain. And there are some private blockchains are also there. A private blockchain is a private property of an individual or organization. There is one in charge of the important things such as read, write, or whom to selectively give access to read, or vice versa. There is a consortium based or federated blockchain is also there. So in that case, more than one persons are in charge of making out decisions. A group of companies or representing individual come together to make a decision for the best benefit of the whole networks. Like some example are R3 or AWS parts are also there. So then we have the smart contract, how this smart contract has been used, and what are the existing blockchain application with respect to smart contract theory. So smart contract theory is basically based upon, let's say a computer protocol is designed digitally to facilitate, verify, or enforce the negotiation or performance of a contract. So it allows the performance of credible transactions without the third party auditing. So these transactions are traversable and irreversible. So as all of you know that the hash function that we have defined is a one-way hash function. It's not two-way hash function. So one-way hash function is this: only we take a value from an input set, and from this input message we will generate a digitally fixed length of size of hash, and that is using that hash we cannot make an irreversible process. So that's why you can see that the value which has been generated by miners, and which are transactions which are supposed to become as a part of blockchain, so those are becomes immutable, or those cannot be changed out, because every value has some hash value. Every data has some hash value which is generated by SHA-256 bit hash code. And even if we have make a certain change, so we will get new hash value, so that value cannot be reversible. So that's why you can say that whatever value that has been written as a part of the data in the blockchain, so that is irreversible, so we cannot change it randomly. Similarly, transactions are traceable in the sense that each transaction has some timestamp associated with that. So once those transactions are having some timestamp, because each block has some certain attributes, so we cannot making out irreversible we can say operation, and each one of these transactions is traceable, because we will be able easy to we can say trace it out when those transactions have been committed in a blockchain network. So you see that smart contract theory architecture is based upon, let's say that we can have some data associated with the particular transactions, and then we have certain conditions associated with that. But these messages which are supposed to become as a part of this chain, so they are signed by the message sender, and if there are enough points for the payment, then message will be added to the blockchains. So you can check it out that these we can say concept these concepts are very relative with respect to the execution of blockchain networks as far as the I mean to say here execution of different transactions are concerned. So this is based upon decentralized autonomous organization. That is, an organization is represented by rules encoded as a computer program. These computer programs, which are transparent, controlled by the shareholders, and these are not influenced by any centralized government. So these decentralized autonomous organizations were the largest crowdfunding in history, having raised over $150 million for more than 11,000 enthusiastic members. So that's the beauty of this blockchain networks. Then there are existing, we can say, blockchain application nowadays. So one of them is a lottery without smart contract. Here we have some organizers are there. Here we have some, we can say, participants are there. These participants, some lottery terms and conditions have been identified, and there is some sort of payment terms and conditions are there. There is company statistics are also there. So I mean to say here that here we have a centralized authority, and using this escrow account, all these payment providers which are sending money to this organization, he will pick up one of those winner from these participants which are participating in this lottery without smart contract system. But now you can see that this earlier mechanism of centralized authority of lottery winner has been revolutionized, and now it has been shifted to this smart contract system, where we will have a smart contract which is bind between organizers, different organizers and participants, and all has to be done in a centralized manner. Now everything has been placed on the blockchain. So now question arises is that if this smart lottery contract system has been launched from centralized authority to decentralized peer-to-peer network system on blockchain, so how it can be, we can say, becomes a fully, we can say, commercialized, or we can say a more attractive system as compared with the earlier part. So you can see that if we move it to the we can say centralized, from centralized to distributed system, then we can easily verify and validate that who are the persons which has committed the transactions at what particular instance of time. And moreover, we can also specify that whether a particular organizer has laid down certain conditions which are fulfilled by him or not. So that's the beauty of this smart contract system, that now everything has been written on in a smart contract which is to be executed by these organizers. And using those smart contract, each participant knows when and where those transactions or data has been committed by or executed by these smart organizers. So that's the beauty of this lottery system. Then second thing is group wallets. So this group wallets is this, that it will enforce at least 2 out of the 3 people in a group to agree to create a valid transactions. Like these other persons, these 3 persons are on the blockchain networks, and out of these 3 persons, if 2 of them are agreed to create a valid transactions, then only this transaction will become valid on the blockchain network. This is just like a more than 51% consensus algorithms. So this enforces that a transaction must be signed either by these 2 parties after 5 years, and these bitcoins are to be transferred into their accounts. So then we have a secure storage is also there. So this enforcing that a transaction must be signed either by 3 devices in different locations, or a recovery key deposit in the bank after 8 months. So these are the different we can say stakeholders, and these whole data has been placed on blockchain networks. So I mean to say here there are number of applications which are used for on these blockchain networks. And in the, we can say, next classes, we are going to have you a practical demonstration on Ethereum and Solidity, that how you can create your own blockchain and smart contract system using Solidity. So Solidity is a we can say language that has been used for creation of Ethereum based smart contract system, which is very much popular for creation of smart contract system to bind it out. And there are various types of blockchain cases. One of those cases is, let's say, blockchain use cases that has been used in Dubai, that is tracking vehicle ownership with blockchain. So here we have different nodes association, like starting from the regulator or manufacturer system. We have the first intermediate is our dealer. So you can see that this regulator or manufacturing consisting of some database, and then we have the dealer association after this. Then we have leasing companies also there. Then we have leases also there. Then we will have scrap merchant is also there. Then we have regulators is there. So you can see that there are a number of steps, or we can say there are number of we can say parties that are involved in this blockchain networks, and we have to track it out, who's the vehicle ownership. So that can be done because each of these entities or nodes are acting as a decentralized peer-to-peer controller, and using those decentralized peer-to-peer controller, they have a shared ledger, that is record of asset transfer. And uh, uh, there is a smart contract that is condition for asset transfer. Like for example, this party wants to buy or lease some car. So obviously he has the full knowledge of asset transfer, to whom that asset has been transferred. I mean to say here, if one buyer is at here, one buyer is, let's say, at some other location. So he knows the full circle on this blockchain networks, that who is the original buyer of that vehicle, and from whom that buyer has to be from whom that car has to be buy, and what are the various types of we can say third party, second party, or fourth party buyers for this particular vehicles. And using the smart contract system, they can easily trace it out, the whole chain of buyers from this blockchain networks, that would be useful for him to buy and check out who's the original owner of that car, which is to be bought by that particular person in a given interval of time. So this was the one of the use cases. So now we move on to another part, that is I'm just sharing, so just hold on. So I hope it is visible. I hope it is visible. So I mean to say here that we are basically moving from a centralized database repository to a peer-to-peer transaction-based system, that is a blockchain system. So earlier, what happens that as I have already told you, let's say two parties are there, Alice and Bob's are there, right? And then they are want to have some transactions with each other. So if they have to make transactions with each other, then these transaction needs to be validated and verified by some centralized authority, and the centralized authority will check the credentials of this person and this person, and then they will be able to transfer the amount from this particular person to this person. But now you can see that it is all about a peer-to-peer based mechanism, and each this also Alice also maintains the public ledger. This also maintains a public ledger, and this also maintains its copy of the blockchain. This also maintain a copy of its blockchain. And once we have some certain consensus-based mechanism in which both of these parties are stakeholders, so they will verify each and every transactions that needs to become as a part of the blockchain. So now you can see that instead of making out the transactions, let's say Alice and Bob's, Charlie, or some other persons are involved, so they are clearing stock settlement through the clearing of houses. So let's say these houses are we can say clear, or these houses are bought, or these houses are sold. So whole data has been placed on the blockchain networks, and then using blockchain, this whole scenario can be viewed like this. So a company also maintain its own ledger, this person 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 also maintain its own ledger. So they have the record keeping mechanism, and this blockchain has been replicated on this node also, this node also, this node also, this node also, and this node also. So this is peer-to-peer based trading mechanism, and using this peer-to-peer based mechanism, notion has been introduced by these two guys in 1991, that is Stuart Haber and then Scott Stonetta. So these are the two persons. They have an idea that how to timestamp a digital document in any generalized scenario. So a blockchain, basically, if you have to give a definition, there is a growing list of records, and these growing list of records are called blocks that are linked using cryptographic hashing, as we have already discussed. So cryptographic hash of the previous block, timestamp, and then we have some transaction data in the blockchain network. So like for example, yesterday also we discussed that how this blockchain has been created. So you can see that this blockchain networks consisting of these number of, let's say, 3 number of blocks, and this is a cryptographic hash mechanism. So the first block in each of these chain is called as a genesis block, and we have the previous hash value, that is, and then we will have this hash value. So this hash now becomes a part of the second block. So this hash value must be same with this hash value. Similarly, this hash value of this block should be the same hash value of the previous block. So you can see that I have already told you that if we have certain attackers attack on this, let's say on this block itself, so subsequent value of all the hashes from this block onwards, 3 to let's say 10, or let's say 100 blocks are there in this blockchain. So these values would change it out, right? So it's very difficult for the attackers to attack on the blockchain, because in that case he has to change all the hash values of the subsequent block, which is very difficult in a real-time scenario in a given interval of time. So there are different, we can say, hash algorithms. One is that it is consisting of some range association from the given input value. It should be, the hash algorithm should be uniform, it should be efficient, and it should have should be follow the Avalanche criteria. The Avalanche criteria is that if we will have more than one, we can say we will have more than one value corresponding to a given hash function. So that Avalanche effect should also be there. Deterministic should be also be there. It should be able to determine the value association. Like for example, after execution of each hash algorithm, we will get a certain definite value. So if corresponding to a given input value, if we will able to generate a number, then that is called as a deterministic. It should be a one way. It should have some it should be able to have tolerant collisions. Collision means to say that if we have defined two hash functions, so they should not map onto a single output value. So it should be collision free. We can say hash function should be there, right? So all in all, if we have to say that how data tamper can be used it out, so you can see that starting from this Genesis block, we have the block 2, block 3, block 4, let's say block 1,000 or millions of blocks are as a part of the blockchain networks. And then the condition here is that we should have the value association or hash code for the previous block and the number of transactions, timestamp, and block ID. So if we have to add trust and security in the blockchain network, so this blockchain, let's say this is the chain of blocks, this is replicated across multiple location in a distributed manner. So you can see that these blocks, these are the blocks, let's say 1 2 3 4 5 6 up to 10. So these are replicated across different nodes in these blockchain networks across different location, and these are we can say located, or we can say replicated in a distributed manner on each of these blocks. Sorry. So you can see that each node contains the copy of the blockchain, and let's say some attackers attack on this blockchain, and he has changed the hash values of all these. So in that case, what will happen, that this once we have to make some we can say decisions, or miner has to take some decisions, then subsequent hashes, subsequent chains, this chain will becomes an invalid chain, and this will not be coherent with this chain. So at once we will be able to identify that there has been some attack on this blockchain networks, because subsequent blocks will becomes invalid, and this whole chain will becomes invalid while this chain is becomes valid. So there will be ambiguity with respect to the execution or mining of the data from the whole blockchain network. So that's why you can see that it's very difficult for the attackers to attack on this type of scenario where we have multiple copies of the same blockchain across different geographical locations, and this has been kept in a distributed manner across different computers. So it's very difficult to compromise all of these computers in a unit interval of time, and that's why it's found to be more secure in any generalized scenario. So mining a block in a blockchain consisting of previous block hash, and this consisting of data, that is multiple transactions. Then we will have the block number, that is fixed, and number, that is nonce, that is timestamp, is a variable. So it means to say there are 4 attributes that is primarily concerned about the values association in a block. That is first is block number, that is fixed, block number 1, block number 2, block number 3, block number 100, and block number 1000. Then we have data, that is how many number of multiple transactions can be added in the blockchain in a block. Then previous block hash and nonce. So nonce, we have to adjust the nonce in such a way that the current hash of the block is less than a threshold value. So this is a very difficult cryptographic challenge or puzzle a miner has to solve it out, that what should be the value of the nonce and how to keep this value in a current hash of the block below a threshold value. So that's why you can see these miners needs to be rewarded, that because they have to do a lot of work, and that is called the proof of work or proof of stake, that how the nonce which has been generated using the current hash of the block should should have value less than a predefined threshold value. So we can have using a brute force a mechanism here to find it out the exact match, so that these hash values should have a predefined threshold value. So it's very difficult task. So that's why we use the concept of mining, and mining is nothing but it's a cryptographic puzzles that is very hard to solve it out. Like for example, we have to have, let's say this is the minor node. So we have some reward for this minor node in a blockchain networks because he has to solve a puzzle. And puzzle here is that whenever it has to generate a hash value for a current block, so that hash value should have a should be below than the predefined threshold, because in that case we will say that the miner has solved a complex cryptographic puzzle. And once he has solved a complex cryptographic puzzle, then we will say that the miner has to be rewarded by some cryptocurrency, by some Bitcoin in his wallet. So you see that this is a very generic view of rewarding that what we call it, rewarding that particular guy who has performed certain task. And using certain task, you can see that we will be able to generate some sort of revenue for this miners who has solved a particular problem. So cryptographic puzzles are hard to solve, but it is easy to verify. So if we have to protect it, protecting a blockchain from various types of attacks, so this can be done with the help of consensus mechanism, that is proof of work. So you can see, as I have already told you, that if some attack has happened on this blockchain, so what will happen, that if we have to protect this blockchain from some intruders or from some attackers, then in that case we have to have a certain hash value, and that needs to be verified. Because you see, if certain attackers attack on this blockchain, and then all the subsequent blocks will become invalid, because then in that case previous hash value will not be equal to the into the current hash value in a particular block itself. So it's easy to verify and validate that there has been some sort of attack on the networks in terms of finding out who is the culprit in a blockchain networks. So I mean to say here, by giving a simple statement, that cryptographic puzzle is very difficult to solve it out, but if we have to verify it, that if we have to verify it, इसको बोलते थे पता नहीं, लेक्चर लेना 6 बजे के बाद कॉल कर, 6 बजे के बाद कॉल कर. So if we have to solve it, then we have to find it out that what is the hash value that needs to be kept it out below a particular threshold value. So that threshold value is obviously a random value. So this cryptographic puzzle needs to be solved it out by using some consensus algorithm that is called as a proof of work. And how does it is easy to verify? Because it is easy to verify in the sense that if attackers has attack on these blockchain networks, then even if a small change into the hash value will change the whole, we can say, will change the whole subsequent blocks. And in that case we will say that this whole blockchain will becomes invalid, and that this will be not in sync with this will not in sync with this. So that's why it's easy to verify that this blockchain will become now invalid, and subsequent blocks has not been in line with the current block. So that's why if we have to take care of that's computing chain and maintaining integrity, so if we have to add new blocks after this whole blockchain, then this needs to be verified and validated before it will becomes actually the part of the blockchain. Because if we have to add this block in this blockchain, so all of these blocks will become set invalid. So you can see simultaneously these two blocks are to be added on this blockchain. Like one block has to be added, let's say one block has to be added on this blockchain, and second block is to be added on this blockchain. So this is a subsequent process, this is a concurrent process which is to be there, in which there are two blocks which are simultaneously to be added on this blockchain networks. So in that case, there is a competition between these two blockchain, that which particular blocks will be added into this blockchain, whether this is valid or whether this is valid. So in that scenario, whosoever chain is long, that chain will win it out, and we will keep only one block. Let's say this chain is large and this chain is small, so this will win it out, and then we will replicate this new blockchain on each of these subsequent nodes which are to be become as a part of this blockchain. So obviously this blockchain will be replaced by this new blockchain, which that consisting of more number of nodes or more number of, we can say, blocks. So that's why here is given as a competing chain and maintaining the integrity. And maintain the integrities with respect to finding out the proof of work, that is to be find it out that whatever the threshold, whatever the, we can say, whatever the hash value is there, that should be below predefined threshold, and using that predefined threshold we will be able to find it out or solve out a complex cryptographic puzzle which is used in this proof of work. So it is very easy to validate this proof of work, but it is very difficult to find out a complete, we can say, mechanism or complete solution for solving a cryptographic puzzle with respect to the inclusion of any blocks in the blockchain network, keeping in view that the hash value should be below a predefined threshold value. So in this case, you can see the longest, whosoever is the longest chain, that will wins. So we will have, let's say, at subsequent interval of time, some blocks has been added in this blockchain, some blocks has been added into this blockchain, some blocks has been added into this blockchain, and similarly some blocks has been added into this blockchain. So this whole new we can say changes that have been done in this blockchain, in this blockchain, in this blockchain, or in this blockchain, or in this blockchain, they are replicated, or they are sending out this whole blockchain information with each other, sharing the information with each other, because all of these entities are connected using peer-to-peer connection. So in this scenario, you can see whichever chain is the longest will win it out, and then that chain will be replicated to each and every computer in this blockchain networks. So that's the concept of this blockchain networks, in which common consensus algorithm has been used. So blockchain serendipity is used, that is called as we have to solve the consensus problems, and this consensus problem shows that general agreement is this, that whosoever has 30% votes, that is to be win it out, and whosoever has a improvement more than 50%, so there will be a common consensus algorithm that is there, right? So till now we have discussed about definition of blockchains, and we have discussed about the feature of hash functions, consensus, Byzantine nodes, smart contracts, and then we will have practical applicability to the blockchain, that is whether to commit or abort the results of a distributed commit actions. So based upon the reading of multiple altimeters, agreeing on estimating of the this blockchain network. So you see that Byzantine, what is the genesis behind this Byzantine? So this Byzantine was back in 1453. The Turkish are visiting the city of Byzantine by making a coordinated attack. So this was the city that is called as Byzantine, and there are group of peoples, a group of we can say soldiers, which wants to attack and take capture of this Byzantine city of Byzantines. So their goal was there should be a consensus between loyal generals. Let's say some generals are here. So let's say these are the four group of people. 5 group of people, 1, 2, 3, 4, and 5. So these are the 5 groups are there, and in these all 5 groups there are some journals, and there are a small number of traitors are also there, so cannot cause the loyal to adopt a bad plan. So it means to say that the all of from all of these groups, some of them are loyal, some of them are traitors, and we do not have the identity to the traitors. So it means to say how to make a common consensus among all these traitors, so that we have to capture this Byzantine by making a coordinated attack, and coordinator in the sense that there must be some sort of consensus between them. So some of them are in the favor of attacking this Byzantine, and some of them are not in the favor of making an attack on this Byzantine. So it means to say, if there is some sort of coordination between these Byzantine, between these soldiers to attack on this Byzantine, then only then coordinated attacks can be launched on this city itself. So this was the story behind this. So same is have been there on this consensus algorithm, that if we have to make a Byzantine fault tolerant algorithm, keeping in view of the transactions that needs to be made on this blockchain, so how to replicate or how to make an efficient decision with respect to this scenario. So this was the story behind this. So there is some sort of algorithm or theorem that shows it is impossible condition for making out an attack. So there is no algorithm to solve Byzantine if only oral messages are used, unless more than 2/3 of the journals are loyal. So if we have not more than 2/3 of the journals loyal, then it's very difficult to capture this Byzantine. So it means to say it is impossible if n is less than 3f for n processes, and out of these n processes, f of which are faulty. So this n should consisting of value that is should be less than equal to f. So oral messages are under control of the sender. So sender can alter the message that it received before forwarding it. So that's why this is called as a Byzantine fault tolerant algorithm. So that we have already discussed. That is, proof of work is computing chain and maintaining the integrity. So whichever chain is longer, that will becomes or winner, and then we can replicate that chain onto all these systems in a subsequent manner, so that this whole concept of computing chain can be removed, right? So then the next part is smart contract. So smart contract is nothing but it is a program which execution is whose execution is autonomous, and it is totally transparent. So in particularly, if you have to take that this execution cannot be reverted and trace is public and immutable. So you see that how this traditional contract system has been executed. So traditional contract system has been executed with respect to this mechanism that we have already discussed. It consisting of paperwork, that is some sort of definition would be there, some sort of audit or semi-annual data collection mechanism is there, and finally we have some law binding association with that, that is interaction between human and objects, and possible application of punishment or definition can be interpreted with respect to continuous trial. So these smart contract, although this processes has to be done or replicated using smart contract, but this is the usual process or traditional process of contracting between two parties or more than two parties, that there is some sort of definition or agreement between these parties, there is some sort of audit or controls, and then finally execution of these or making out plan between different parties. So this process would be like this, but now this has been completely replicated or replaced with the inclusion of smart contract, where we have some software programs that is used to make a definition or legal binding between two parties, so more than two parties. Then we have certain audit controls, that is real-time transaction transaction keep transaction record, and using these smart contract system, we can have a real-time immutable ledgers, because you see that once we have making a agreement between two parties and using cryptographic hash function, we will protect all the transactions that are supposed to become as a part of the blockchain. So if we change certain values, then we have to create a new hash value. So that's why you can see that it is immutable, so we cannot change it. So if we have to change it, then in that case we have to generate a new hash value. So that hash value remain invalid if we have changed certain data elements in a blockchain network. So that's why this whole process needs to be made fully automated with respect to the definition, with respect to the audit control, and with respect to the execution. So program execution is again the whole execution of these programs cannot be reversible, because we are using one-way hash function, so it should be autonomous also. So like for example, insurance claim is there, so we can have the insurance claim for the using blockchain networks. So one of the part of creating a smart contract is Bitcoin. So Bitcoin is nothing but it's a program. Its execution is totally autonomous because of the decentralized networks. So in this case, every transactions are public. So it's not possible to modify the history of transaction. The execution cannot be reverted. So few clauses of the statement of this contract is that no more than these bitcoins should be there. New blocks every 10 minutes can be created. Mining difficulty is adjusted to the power of the networks, and only subset of possible transactions are allowed. So till now, what you people have taken it from the discussion is that we have discussed about hash functions, we have discussed about proof of work, or we can say mining ability of different miners, and how those miners are mining the transactions, and how the smart contract can be designed, and what are the new currency basis are available, and solution to the area that can be applied in different area. So you can own a peer-to-peer networks that is running on the top of internet, and properties are both centralized and distributed in a blockchain networks. So what are the various types of benefits of using the blockchain? So the key benefits of using the blockchain is that it is decentralized. There is no need of trusted third party in the blockchain networks, and it consisting of transparency and trust. So because it's consisting of immutability, that is highly availability, highly secure, and simplification of current paradigm is that is consisting of single shared ledger, right? And it's consisting of faster dealing, and cost saving mechanism is also there. So there are some sensitive issues with the blockchain, that is, if we increase the scalability, if we increase the number of nodes in the blockchain, how does we will be able to make a scalability, adaptability, regulations, relative immature technology, and we have to have making out the privacy. So applicability is that most of the times it has been used in cryptocurrencies, finance and market, health, media, and any field that can use require distributed ledgers, consensus, smart contract, digital right management, operational efficiency with trust, and at a low price. So let's say I have given you example that if we have to create a stock settlement through clearing houses, so these clearing houses earlier has to be have based upon some centralized contract system, where everything needs to go to this centralized contract system, and from this centralized contract system verifies the identity of different persons involved in this smart contract, and then issue the certificate or abide by the rules and regulations from these parties. But now this whole mechanism has been shifted to completely decentralized system, where each of these entities are becoming a stakeholder, and everyone keep their own ledgers and blockchain. And if let's say this makes some changes in the blockchain, so that can be replicated on this blockchain networks, right? So this is a peer-to-peer trading mechanism, where we have a trading which is to be taken care of with respect to maintaining the distributed ledgers at different locations. So there are certain applications of the blockchain also. First application is that it is used for securing the chain of custody of evidences, and it is used for standardizing distributed crime reports. It is secure, interoperable, emergency data sharing, decentralized emergency alerts and response structure, decentralized oversight, etc. So there are companies that are working in law enforcement is that they needs to have crypto seal, like tamper-proof blockchain, registered container for evidences from chronic, and that is Lenovo's, that is blockchain evidence lockers, BCOC, that is corner library paper detailing what requirement a blockchain of custody should include for evidences. China Ministry of for Public Security, this using the blockchain for evidence chain of custody. Bitfury is a crystal blockchain, is an early use case, not only for blockchain analyst, but future system for tracing criminality. So there are a number of, we can say, organizations or companies which are involved in law enforcement using blockchain. That is Deloitte is government practice shared how blockchain could help with intergovernment transparency, and Guardian Circle decentralized P2P emergency services. So we can also have a cross-border payments. That cross-border payment can be done using Ripple or Circle or BTrade. So this allow the user to safely transfer the money in multiple supported currency to over 29 countries. And Ripple also helps the bank, payment providers, and digital asset exchange to send and receive money globally super fast with minimal remittance fees. So this is also there in the market. WeTrade offers an innovative digital platform that enable bank and businesses to work collaboratively across Europe, offering secure, transparent, and various types of opportunity. So we also have the supply chain management using blockchain, and this provides interoperability and the transparency in data sharing, make sure that everyone is on the same page. So all the products can be tracked in a real time, and scalability. So it has scalability issue provision also. So it consisting of let's say supply chain management is origin train, that is they offer a data exchange protocol that can be used for interconnected supply chain, and open port is a blockchain platform that directly connects shippers and carriers, which helps to reduce the cost and optimize supply chain management. Walmart, one of the biggest retail shops, are utilizing blockchain to improve its supply chain management. So there are a number of supply chain management that are associated in a blockchain networks. Also in real estate, Propi, they are one of the first company to introduce the use of smart contract in buying and selling the real estate. The first transaction made using their system was $60,000 in Ukraine. Property Club, it is New York-based startup that offers a blockchain-based power system where people can buy, sell, and invest in real estate by leveraging the smart contract system. And it had been used in sports and esports also. They can sell even tickets, creating channel subscription to see a live games. Sporting Co, that is company, offers crypto sponsorship for athletes. And player tokens, the company helps to tokenize player to promote for the fan participation. So there are a number of companies that are involved in blockchain. Similarly, in healthcare, so this is healthcare is again decentralized log of patients' data. That is Bust IQ. The company provides blockchain-based solution to help the healthcare company manage the massive amount of patient data secure and safely. Medical claims, medical chain, that is helps to maintain the integrity of the health records. Doctor, patients, and hospitals and laboratory can request the patient information, but the patient identity remains safe and protected from outside sources. Other patient data management companies are also using this blockchain like DocChain, Patientry, Gem, GuardTime. There are no number of, we can say, solutions that are already available on the blockchain networks. Like we can trace it out, drug traceability like SAP Pharma blockchain, POC app, Novartis. There are clinical trials are like Amgen, Pfizer, and Sanofi. So they can use claim and billing for the customers also using the blockchain networks. So application of the blockchain that is based upon features like we should have some trust management mechanism, that is trust and removal of any centralized authority, because we are moving from the centralized authority to the completely wholly distributed systems. So you see that when we talk about the blockchain network, so this consisting of transparency and transactional efficiency within the banking and payment and transfer system. So on the other hand, if you talk about immutability, so this consisting of that whenever one record has been used, then that particular record cannot be, we can say, change it out because of the secure cryptographic hash function that had been used, and it is completely tamper proof, that can be used in voting system and online music systems also. And this smart contract is again, it is not a centralized hands, so it had been used in real estate, energy trading, and insurance companies also can use it out. So I mean to say here that you can name any application where we have a supply chain management system where we have some sort of transactions with respect to the financial constraints. So all of these applications use this blockchain network. So we can name a few applications like here, like we have the insurance management, we have the payment and cryptocurrencies, and then more or less we have energy trading mechanism, and then we can have a trade and finance, healthcare, music, real estate, government, banking, supply chain management, retail, consumer product, transportation, digital identity verification and validations, cross-border trade payments, precision medicines, and you can name any applications, and all of these applications are abide by the mechanism that we have already discussed, that all of these applications are based upon constructing a smart contract. So once the smart contract has been constructed between different parties, so these parties are abide by those rules and regulations, and using those rules and regulations we can create our own blockchain, which is used to make the communication between different parties in a seamless manner. So how this cross-border payment has been done, like there may be a slow cross-border payment is there, so we can introduce a faster and transparent payment gateways. And if there is some sort of costly supply chain management system, so we can get rid of fraud with real-time view and increase the value. So in other cases, using this blockchain networks, we can get rid of and time tracing of our assets, where those assets are there, and how many clients are involved in trading of all those we can say transactions which are supposed which is happened in a particular instance of time. So all those frauds or real-time tracking of all those events can be done with the help of blockchain, and that increases the we can say complete foolproof system with the increase in the revenues for the service providers, as well as only less loss to the consumers also. On the other hand, if you can view that if we have accountability issue in traditional contract system, so we can make a smart contract system that offers complete, transparent, and fast settlement for different stakeholders, including clients as well as service providers. So this is a very efficient system, and using this efficient system, we can make real progress, or we can check it out that how I mean to say here that how the tracking of different assets can be done using blockchain. And on the other side, if you can check it out, if there is a mismanagement in healthcare organization, like we are not able to trace out where those drug delivery system has been implanted in human bodies, so you can protect and store patient data with full transparency, and you can perform various operations. So it will be very easy for the doctors also to verify and validate the transactions which are supposed to become as a part of the blockchain. And because the whole thing has been placed in the centralized database distributed database repository. From this distributed database repository, every stakeholder can verify and validate those transactions, and they can access it from it anywhere, and they can perform various types of operations. On the other hand, if you have to maintain the digital copyright and piracy issues, so these digital copyright and privacy issue can also be handled with the help of usage of blockchain, because it offers decentralized copyright, privacy, and tracking and validations of a legal document. So this can be we can say easily verified and validated the culprit who has changed the original we can say paper by making up some sort of attack. Then if we have a slow convergence systems, so this whole we can say slow convergence system can also be tackled using the blockchain system also. So all in all, you can see that it is a completely decentralized system which is very efficient with respect to the implementation in different applications. And if we have inadequacy in real-time asset management or real estate scenario, so those can also be addressed with the help of designing a smart contract system which is to be replicated on different buying and selling processes to different buyers and sellers. And on the other hand, if we have unfairness in sports and esports, so those can also be focused with respect to designing policies in the blockchain networks. Or if we have to find out corrupted crowdfunding, or we can say fundraising, so those can also be handled with the help of designing smart contract using real-time tracking and immutable solutions in a blockchain networks, right? So I mean to say here there are a number of applications which needs to be dealt with blockchain networks, and all of these applications are based upon smart contract system. And the key components in designing a secure hashing mechanism using proof of work and proof of stake algorithms itself, right? So I hope this point is clear to all of you. So you can see I mean to say here that I have given you a simple example that how this supply chain management and monitoring with respect to fraud management, efficiency, and reduction in cost of sending the information between buyers and seller can be fully automated using designing blockchain networks. We can have uh, uh, this using KYC with faster money transfer, low fees, and better visibility to all the stakeholders, digital identity, copyright protection. Digital voting is also a new concept that it is fully transparent, hassle-free, and universal. So any voter can vote it from any locations, and this is completely decentralized system. Then real estate, then charity funds, trading mechanism in pharmaceuticals companies, then asset management in a supply chain management or in a store itself, then insurance claims, then certification validations, medical record keeping. So there are, I mean to say here, thousands or millions of applications in which these types of blockchain can be used to verify and validate each and every aspect of a particular transactions. So this was the I mean to say here basic components of any blockchain networks that is to be used in different applications. So we will have some real-time demonstration for the same also, so that we can check it out how if there is some sort of attack on the networks also, then how these attacks can be identified with respect to finding out a solution for the blockchain network. So I'm sharing you some we can say some blocks. So what we have discussed till now is that let's say I hope this is visible to all of you. Is it visible? Hello,
Yes, sir.
is it
Yes, sir,
visible?
it is.
Yeah.
Yes, sir, it is clearly visible.
Okay, thank you very much. So now you can see that till now we have discussed about the basic components of the blockchain. I hope this is clear to all of you. So you see that these we can have, let's say, these finite number of blocks in a blockchain, right? So I have told you that blockchain has consisting of certain blocks. So I mean to say here that different attributes are associated on the blockchain in each block. So let's say first attribute is block number. So let's say this is block number 1, block number 2, block number 3, and then we will have certain nonce. So nonce are completely, I mean to say here, number is there. So this is called as a timestamp. So this will keep track of at what particular instance of time this blocks has been created, right? So each blocks has certain time interval. So let's say this block has been created at 4:30, this block has been created at 4:45, this block has been created at 5:45. So you mean to say here that these nodes are used to keep track of at which particular instance of time these blocks are created. So these blocks can be created at different interval of time, and then we will have certain data associated in these particular blocks. So I'm entering some data. Let's say I'm fine. So in this case, you can see some yellow portion is there. So why this? Sorry, this pink portion is there. So pink shows that these blocks has not been verified. So there are basically 5 attributes for this particular, for each block. First is block ID, then we have nonce, then we have data, then we have previous hash, and then we have current hash association for that particular block. So once you have entered certain data into this particular block, so there must be some consensus algorithm. We have already discussed that. So let's say I'm in Patiala. So you can see that this particular part, each time you increase, each time you enter some value at here. So keep watching on this part, because this hash value abruptly change. Even if I change some, add one character, so we have generated a new 256 hash code. So even if I entered one character, so you can have new hash. Similarly here also, if I add new values, so let's say this new hash has been added, so we have new hash, we have new hash. So you can see that once I mine this block, so it takes some time. So once I click this mine, so you can see that this becomes green part. So is it okay now? I hope you understand what does it mean. Is it okay now? This block has been mined, right? So now again I mine this block. So this block number 2 has been mined. So and then I click this portion. So this block has also been mined. So you can see at here that earlier these blocks color was pink, but now once you have mined those blocks, so this color of this block will becomes green. So you can see that now if at particular instance of time, let's say we have some attack on this block, right? So let's say this block has been attacked, right? So this block has been attacked in the sense that I have changed its value. right? So you can see that I have changed the value in the data of this block. So all these subsequent blocks will becomes invalid. Is it okay? Right? If I remove this, so this will becomes a completely mine block. So this is a valid block. But as soon as I change only one character, so you can see we have a new hash value, right? So this previous hash will not match with this hash. This hash value should be equal to this hash value, like here. So this hash value is completely same with this hash value. So this hash value and this previous hash values, both hash values are same. But now you can see I have changed the value of this data. Let's say I have entered only one character. Now this hash value would be different from this previous hash value, right? So it means to say from block number 3 to, let's say I have 1000 of blocks, only these two blocks and 2 are main valid, and rest block number 3 to 1000 will becomes invalid in this blockchain. So if attackers has to take control of this whole blockchain, then he has to change the value for this block, for the block number 4, block number 5, and subsequent till 1000 block, which is a very difficult and impossible task to be performed. So in nutshell, we can say that if we attack on the blockchain and then change abruptly some data on the blockchain, then he has to capture all the blocks, subsequent blocks, which is on the blockchain networks, and blockchain itself does not contain 2 or 3 blocks in the blockchain. So they may be consisting of millions or billions of blocks that may be distributed across different geographical location in an environment across the globe. So it will be very difficult or almost impossible for the attackers to attack on the blockchain networks with the help of designing new solutions, or with the help of designing new attacks on this blockchain. And again, they have to start from the initial part, and that will be very difficult for them to make an attack on this blockchain networks. I hope this point is clear to all of you. What does it mean? And if you, I have already given example that how we can generate. You can see, let's say I'm fine. So we have a certain hash value for a this particular data, because we are using SHA-256 SHA-256 hash algorithm has been used, and you can check it out. Keep an eye on changing value of these hash values. So if we are just changing some, even if one bit of data, so we have a completely new hash value of 64 characters with 4-bit character, or with 4 bit for each character, that is 256-bit new hash value has been generated. So it's completely fine that once we have changed even a single character in a of data in a blockchain network, then we will get a completely new hash value, which is to be I mean to say here, which is completely different in a particular part itself. And in each block you can see that if we will enter some values, so this chain will becomes increasing, and we have a completely new hash value for these blocks. So these knowns remains constant, because these two attributes I mean to say, are used to verify that we are dealing with some block number, and we have some nonce, that is timestamp, that is when that particular block has been created. So on the other hand, if you can view that we have certain values that is to be entered as data element in a block, then if we have certain hash algorithm, that is SHA-256 algorithm, so that SHA-256 algorithm create a completely new hash value for each blockchain. And if we have to mine this, so after mining it, Obviously this mining has been used during the proof of work. So this mining has been done at here, but now you can see if we again enter one character, so again we have to mine it using consensus algorithm because we are changing the data. So if I'm changing the data, then obviously I again have to mine it. I have to use the proof of work or proof of stake consensus algorithm, and once those proof of consensus or proof of stake algorithm has been executed, so we have to take care of this what we call as a new value, which is completely we can say different from its previous value. So it's very difficult for the attackers to attack on the blockchain networks. I hope this point is clear to all of you, right? It's okay. I hope it is okay. Okay. So we stop at here. Tomorrow we will have a new discussion on continuous improvement uh, on this topic. That is, we will move slowly towards the basic building blocks to advanced building blocks, and then we slowly move on to the creation of smart contract in Solidity and Ethereum, and which is a very important topic as far as the practical implementation of this concept is concerned. So regarding today's lecture, if you have any queries, so please raise your queries. So I'm happy to answer your queries. Any queries from your side?
Hello.
Hello, sir.
Yeah, please go ahead.
Sir, you told us the reason why two blockchains get merged.
Yeah.
So, sir, can I know why two blockchains split?
You see, let's say in one blockchain we have. You just mute yourself, please. First of all. Okay. So you see that if we will have a 10 blocks in one blockchain, and if we will have 11 blocks in another blockchain, so if we want to add new blocks in the blockchain, right? So simultaneously we are adding two blocks, one in blockchain which has 10 blocks, second in a blockchain which has 11 blocks. So there may be inconsistency with respect to the blockchain management with respect to the inclusion or removal of one block from the blockchain. So that's whosoever is the longest chain that will win it out. So that's why because that a new chain will replace the existing chain. So let's say if I'm able to successfully add a one block in the blockchain which has 11 blocks, so now it has 12 blocks. So this 12 blockchain now will replace the 10 block blockchain, because this is the newer version which needs to be replicated on each and every node so that a common consensus algorithm can work it out. So this is the reason for the same.
But sir, then now there is only one blockchain left
No.
at the end.
That you what happens that needs to be replicated on each and every node itself.
Okay, sir. And sir, one more thing.
Yeah.
Sir, like buying game points in games are the example application of blockchain.
Which one? Games?
Yes, sir.
Yes. Games means
Yes, sir.
first
Like buying game points or
you
stuff in
kindly
games.
unmute yourself because echoes is there, right? Okay, so you see, if you have to win in a particular game, or if you have to, I mean to say here, buy games online. So this is also a fully distributed. This can also be a fully distributed system. For fully automation of this, you needs to again add to sign smart contract between service providers and consumers, and this can be fully automated with respect to the revenue generation for you people's rather than a traditional contract system, because this system can be fully automated using the blockchain networks by buying games from the service providers and using, because you see there are multiple
Okay, sir.
parties
Okay, sir. And sir, by the first question, by my first question, I mean to ask that what result in generation of a new blockchain?
what results in generation of new blockchain.
Yes, sir.
I mean to say here that because I have given you example that there are multiple blockchain and there are multiple same copy of that blockchain that is replicated on multiple nodes. So if I have to add let's say new block, that should be synced with the other blockchains that are located on different nodes itself.
No,
So if
sir, are you
add,
saying block? Sir, are you saying blockchains and block are same thing?
no, blocks are integrated or blocks are integrated or connected just like a chain as a cryptographic hashing algorithm. This whole chain consisting of, let's say, 1,000 blocks. So block is a one part, but chain of blocks will become blockchain.
Yes, sir. Yes, sir. I am asking that question, that what result in making a new block? Like you told us, the when
Because
there
I
is
have shown, yes, I have shown you that if we have to change the data or if we have to add new blocks, if we have changed the new data and we have added new data entry into the blockchain, then we create new blocks and new transactions are to be committed in the smart contract system. Then obviously we have to again mine all those transactions, and those transactions are supposed to become such a part of the block. Any other query?
I had a query actually. I wanted to ask, for example, I'm launching my own node in this whole, in a lot of nodes in a blockchain. How does my node, how does my node gets to discover the other nodes? Like either there should be sort of like a client server model where the server has a static address and the other nodes try to find it, but in blockchain it is literally very different because every single person is a node. So how does my node find the other nodes or the other nodes find me?
That is with the help of digital identity, that is called as a digital signature. You can easily trace it out because you see digital signatures are the identity for you people to in a particular blockchain network. So you can trace it out that who is the person who has committed a particular transaction using his digital signature identity. Digital signature is just like an identity of a particular person. Any other query? Okay, thank you very much. Have a nice day, and tomorrow we will have a new topic to be discussed. Thank you, Sakshi.
Thank you so much, Neeraj sir.
Thank you very much.
So the attendance link for today has been shared in the chat window. Just have a look over there. And it will remain active for another 10 to 15 minutes. So everyone mark your attendance on time.